Hi friends, in this session we study about the complex number. First, I would like to define the complex number. A complex number is number that can be expressed in the form of z is equal to a plus ib. Here a and b are real numbers and I is the imaginary unit, which is also called iota, that satisfies the equation I square is equal to minus 1. In this expression, a is a real part and b is imaginary part of the complex numbers. So first I would like to explain what is imaginary number. So because we have studied the real numbers in our previous classes, so first of all I would like to explain you about the imaginary numbers. Imaginary number. So first I would like to explain what is imaginary number. If we have a expression or equation like x square minus 36 is equal to 0. So we could simplify this in two ways. One, we could simplify through the factorization or using the identity what we get the a square minus b square. The other way we could x square is equal to 36. Now if we take the square root of this, so we get here x is equal to square root of 36. So how we get the square root of this? So I explain you further. In the square root, we say the 36 may come through the 6 into 6, or we could write in this way 6 square, and through this the square and the square root will eliminate each other, will divide each other, and finally we get here 6. The other way we could write in this way x is equal to minus 6 into minus 8. This also becomes 36. So we could write in this way here also square and square root will divide each other, or we get here minus 6. So we get the value of x here 6 or minus 6. But if we have to find out the square root of this expression, x square plus 36 is equal to 0. So we use the same technique, we transfer this 36 to other side, it will get minus 36. Now if we have to find out the square root of this, what will happen? We see x is equal to square root of minus 36. If we simplify this, we get here minus 6 into 6. So we could not find out the square root of this number, but we have the other way by which we could simplify this and we could find out the imaginary number. So x is equal to, we could write in this way 36 into minus 1, because the minus 36 we could write in this way. So x is equal to square root of 36 into square root of minus 1. Here this minus 1 is called iota, or it could be denoted by italic I, small I. So we get here x is equal to the square root of 36 is plus minus 6, and this root minus 1 we could write italic I. So x is equal to plus minus 6i. So here also we get this is the imaginary number. The unit imaginary number is root minus 1, which can be denoted by I. Now we see what is complex number. Complex number is the combination of real and imaginary number. Just like if you have to write down any complex number, then x plus yi. Here x is the real part and y is the imaginary part of the complex number. It is the summation of real and imaginary numbers is called a complex number. Here we could represent this complex number. This complex number we could represent on a different sort of graph, which is called complex graph, Argand graph, or Gaussian graph. So in this Gaussian graph we see how we plot the numbers. Like if we take one number like z is equal to 3 plus 4i. So look at here, this axis, the horizontal axis is called the real axis, and this vertical axis is called the imaginary axis. So this is the I, 2i, 3i, 4i, 5i, 6i. These the positives are above the horizontal axis, and the negative imaginary numbers are on the below the horizontal axis. So if you have to plot 3 plus 4i, so here the 3 on the real axis is this one, and the 4i is here. So we get the number here. It is the 3 plus 4i. If you have to find out the z is equal to 3 minus 4i, so it would be 3 is here and 4i is here, minus 4i. So we could write here is the z minus 4i. If you have to find out the number z is equal to minus 3 plus 4i, so we get minus 3 and plus 4i. We could find in the second quadrant. And if we have to find out the z is equal to minus 3 minus 4i, we could get minus 3 and minus 4i here in the third quadrant. So in this way we could plot the numbers on a complex plane. So this is called a complex plane. Now I would like to explain some more things about the complex number. Very important thing in the complex number is the conjugation. So first I would like to explain what is conjugation. A complex conjugate of a complex number z is equal to x plus yi is defined to be z bar is equal to x minus yi, is denoted by the z bar or the z asterisk. Here you see the difference is where this sign of the imaginary part would be changed in the conjugation. If it is positive, we will make it negative. If it is negative, we change it in positive. So it is the geometrically z is the reflection of z about the real axis. Conjugating twice gives the original complex number. So if we twice conjugate any complex number, it gives us the original complex number. So look at here in this figure, you see this is our imaginary axis, this is our real axis, and this is the z is equal to x plus iy. And if we have to find the z is equal to x minus iy, would be here on the opposite side of this real axis. So real axis would be work as a mirror here. So I explain you here also in our previous example. Look at here. Look at here. This is z. This one is our z, which is 3 plus 4i. The conjugate of this z bar is conjugate 3 minus 4i on the below of this real axis. This is the 3 minus 4i. So this is the reflection here we are seeing. If we join with a line, no. So in this way we could easily find out. Now another one we see here, 3 plus 4i. So it is the 3 plus 4 I. Sorry. Now we see z is equal to minus 3 plus 4i. So minus 3 plus 4i is here, and the conjugate of this z bar for this, so minus 3 minus 4i would be here. So we get here this one. And this way we find the reflection of these numbers. Now some more things I would like to explain about the conjugation. If we have to find out the real and imaginary parts of a complex number, Z can be extracted using the conjugate. So the complex number, if we add the complex number with its conjugate and make the half of this, so we get the real of that complex number, the real part of the complex number. If we have to find out the imaginary part of the complex number, then we have to subtract the conjugate of complex number through the complex number and divided by 2i. So we could get the imaginary part of the complex number. Here one another note is here. Moreover, a complex number is real if and only if it equals its conjugate. If you have a complex number like this, Z is equal to 3. So Z bar is also 3 because there is no imaginary part here. So we have to just change the sign of the imaginary part. So in this way we could easily find out the conjugate of complex number. If there is no imaginary part, then it would be the same. So now in the next session we will study in detail about the conjugation distribution over the standard arithmetic operations. So in the next session we study about the operations, arithmetic operations of the complex number, addition of complex number, multiplication of a complex number, subtraction of complex number, division of complex number. Then we see how we find out these all distributive over the standard arithmetic operations of the conjugation. So it is the, if we just I explain here, conjugation of the summation of two complex number is equal to the summation of conjugate of the complex numbers, and the subtraction of conjugation of subtraction of a complex number is equal to subtraction of their conjugates. If we have conjugation of the product of two complex number is equal to the product of their conjugates. If we have conjugation of division of two complex number, then it is equal to their division of conjugates. So this I would explain in detail in our next session. Thank you.